Our solar system is a diverse and wondrous place, filled with planets of varying sizes and environments. Among these celestial bodies, Venus holds a special place in our imagination. Often referred to as Earth's twin, Venus is remarkably similar in size and mass to our own planet. It's the second planet from the Sun, while Earth is the third. This close proximity makes Venus visible to the naked eye, a bright, shining object in our night sky. For centuries, astronomers and dreamers alike gazed upon Venus and wondered about the secrets hidden beneath its thick, swirling clouds. Our sister planet, once a symbol of hope and possibility, turned out to be a harsh and unforgiving world. The thick atmosphere, rather than a nurturing cradle for life, was a suffocating blanket of carbon dioxide. The surface of Venus is a scorching wasteland, hotter even than Mercury. This is not a world hospitable to life as we know it. The allure of Venus lies in its resemblance to Earth and its potential. Could we transform this hostile world into a second home for humanity? Terraforming Venus is a serious scientific inquiry. The challenges are immense, requiring innovative solutions. Yet the potential rewards are significant, a new world to explore. The average surface temperature on Venus is around 462 degrees Celsius. This extreme heat is due to the runaway greenhouse effect. Venus's atmosphere is about 90 times denser than Earth's. The extreme atmospheric pressure on Venus is not just a challenge for spacecraft, it's a major obstacle to terraforming. This crushing pressure would make it impossible for humans to survive without specialized suits or habitats. Even with protective gear, the sheer density of the atmosphere would make movement difficult and limit exploration. Beyond the physical challenges, the atmospheric composition of Venus poses a significant threat. The thick carbon dioxide atmosphere traps heat, creating the aforementioned runaway greenhouse effect. This dense blanket of CO2 prevents heat from escaping back into space, leading to the planet's extreme temperatures. Furthermore, the clouds of Venus are not the fluffy, water-laden formations we're accustomed to on Earth. Instead, they're composed of sulfuric acid, a highly corrosive substance that would eat away at any unprotected materials. These sulfuric acid clouds also reflect sunlight back into space, contributing to Venus's high albedo and further trapping heat. The combination of extreme heat, crushing pressure, and a toxic atmosphere makes Venus a hostile and unforgiving environment. Any attempt to terraform this planet must address these fundamental challenges before any thought can be given to introducing life or creating a habitable environment. The sulfuric acid clouds of Venus are not just a visual spectacle, they play a significant role in the planet's extreme climate. These clouds are formed through a complex chemical process involving sulfur dioxide, released by volcanic eruptions. When sulfur dioxide reaches the upper atmosphere, it reacts with sunlight to form sulfuric acid droplets. These droplets create a reflective layer, preventing sunlight from reaching the surface and contributing to Venus's extreme heat. The heat that penetrates becomes trapped, leading to a runaway greenhouse effect. To grasp the challenge of terraforming Venus, we must understand the runaway greenhouse effect. Similar to Earth's greenhouse effect, it has turned Venus into a scorching inferno. Let's break down the science. The sun emits radiation, including visible light and infrared. When this radiation reaches a planet, some is reflected, some absorbed. Earth's atmosphere allows solar radiation to reach the surface. The Earth radiates some energy back as infrared. Greenhouse gases trap some of this infrared radiation. This warms our planet. On Venus, this process has gone haywire. The thick carbon dioxide atmosphere traps almost all infrared radiation. This creates a positive feedback loop, making Venus the hottest planet. Our journey to terraform Venus begins with a sobering acknowledgement of the challenges that lie ahead. This is not a simple renovation project. It's a complete planetary makeover, a cosmic challenge of unprecedented scale. We face what can be called the three hells of Venus: the infernal heat, the crushing pressure, and the toxic, corrosive atmosphere. The first hell, the heat, is a direct result of the runaway greenhouse effect we discussed earlier. With surface temperatures exceeding those on Mercury, Venus is a planet bathed in constant, intense heat. This extreme heat would melt most materials we use in construction and technology, making it impossible to deploy conventional equipment or establish human settlements without significant protection. The second hell, the pressure, is equally daunting. Venus's thick atmosphere creates a surface pressure 90 times greater than Earth's, equivalent to being nearly a kilometer beneath the ocean's surface. Such immense pressure would crush most structures we could build and would necessitate specialized habitats and equipment for any human presence on the planet. The third hell, the toxic atmosphere, presents a more insidious challenge. The thick carbon dioxide atmosphere is not only responsible for the runaway greenhouse effect, but also creates a highly corrosive environment due to the presence of sulfuric acid clouds. These clouds would eat away at any unprotected materials and pose a significant threat to human health. Tackling the first hell, the infernal heat of Venus, is paramount. As long as the planet remains trapped in its runaway greenhouse effect, any attempts at terraforming will be futile. Our goal, therefore, is to cool down Venus, bringing its surface temperature closer to a range suitable for life as we know it. One ambitious proposal involves using giant solar shades to block a portion of the sunlight reaching Venus. These shades, strategically positioned in space, would act like giant mirrors, reflecting sunlight away from the planet and reducing the amount of solar radiation absorbed by its atmosphere. By reducing the incoming solar energy, we could begin to cool down Venus over time. Another approach focuses on increasing Venus's albedo, its reflectivity. By introducing light-colored particles into the upper atmosphere, we could enhance the planet's ability to reflect sunlight back into space, further reducing the amount of heat trapped by the atmosphere. These particles could be composed of various materials, such as sulfur dioxide, which is already present in Venus's atmosphere, or even engineered materials designed specifically for this purpose. Cooling down Venus will be a long and gradual process, likely taking centuries to achieve a significant temperature reduction. However, it's a crucial first step, laying the groundwork for further terraforming efforts and making the planet less hostile to any potential life-supporting modifications. Section 3, the weight of the world. With the heat somewhat mitigated, we face the second hell, the crushing atmospheric pressure. Venus's thick atmosphere, while problematic, also presents an opportunity. The sheer volume of carbon dioxide in the atmosphere could be seen as a resource, a vast reservoir of raw materials waiting to be harnessed. One approach to tackling the pressure problem involves carbon sequestration, a process of capturing and storing carbon dioxide from the atmosphere. While this is a major area of research on Earth to combat climate change, on Venus, it would be on a planetary scale. Imagine massive, automated factories dotting the Venusian landscape, tirelessly working to extract carbon dioxide from the atmosphere. This captured carbon could then be transformed into various useful materials, such as carbonates for construction, or even oxygen through complex chemical processes. Another intriguing possibility lies in the potential of genetically engineered organisms. Could we create extremophile organisms specifically adapted to survive and thrive in Venus's harsh conditions? These organisms could consume carbon dioxide, converting it into other compounds and releasing oxygen as a byproduct, gradually transforming the atmosphere from within. Section 4, Poison Rain. The third hell, the toxic atmosphere, requires a multi-pronged approach. The sulfuric acid clouds, a product of complex chemical reactions in the atmosphere, need to be neutralized to make the planet hospitable. One method involves seeding the upper atmosphere with chemicals designed to react with sulfuric acid, neutralizing it and converting it into less harmful compounds. This could involve releasing massive quantities of water vapor into the atmosphere, which would react with sulfuric acid to form sulfuric acid hydrates, a less corrosive and more manageable substance. Another approach involves using genetically engineered organisms, similar to those proposed for carbon sequestration. These organisms, specifically designed to tolerate the acidic conditions, could consume sulfuric acid, breaking it down into less harmful substances and further contributing to the transformation of the atmosphere. Neutralizing the sulfuric acid clouds is crucial, not only for making the atmosphere less toxic, but also for reducing the planet's albedo. With the reflective sulfuric acid clouds diminished, more sunlight would reach the surface, potentially aiding in warming the planet once the runaway greenhouse effect is under control. Section 5. A change in the air. As we address the three hells of Venus, we must also work towards transforming its atmosphere into a more Earth-like composition. This means reducing the concentration of carbon dioxide and introducing nitrogen and oxygen, the two main components of Earth's breathable air. The carbon sequestration methods discussed earlier would play a crucial role in reducing carbon dioxide levels. As we extract and utilize carbon from the atmosphere, we create space for other gases to take its place. But where do we get the nitrogen and oxygen needed for a breathable atmosphere? One possibility lies in the vast reserves of nitrogen trapped in the rocks and minerals of Venus's crust. Through various geological processes, such as volcanic eruptions or artificial drilling and extraction, we could release this trapped nitrogen into the atmosphere. Oxygen, on the other hand, could be produced through the process of photosynthesis, just like on Earth. Once we have introduced water and created suitable conditions for life, we can begin to introduce photosynthetic organisms, such as algae or genetically engineered plants, which would release oxygen as a byproduct of their metabolic processes. As we manipulate Venus's atmosphere, we can further influence its temperature and climate through the strategic placement of giant mirrors in space. These mirrors, working in conjunction with the solar shades mentioned earlier, would allow us to fine-tune the amount and distribution of sunlight reaching the planet's surface. Imagine a series of massive orbiting mirrors, each capable of reflecting sunlight onto specific regions of Venus. By carefully controlling the angle and intensity of the reflected light, we could create areas with varying temperatures, simulating day and night cycles and even influencing weather patterns. These mirrors could also be used to illuminate the planet's dark side, which currently experiences perpetual night due to Venus's slow rotation. By reflecting sunlight onto the dark side, we could create more balanced heating and potentially stimulate the growth of photosynthetic organisms, further accelerating the terraforming process. The use of space-based mirrors represents a powerful tool in our terraforming arsenal, allowing us to precisely control the amount and distribution of solar energy reaching Venus and shaping its climate to our liking. We stand at the precipice of an audacious endeavor to tame the fiery heart of Venus and transform it into a haven for life. Our first line of attack involves reducing the amount of solar energy bombarding Venus. Imagine a vast fleet of orbiting mirrors, strategically positioned to intercept a portion of the sunlight before it reaches the planet. These mirrors, acting like celestial parasols, would reflect sunlight away from Venus, gradually diminishing the energy absorbed by its atmosphere. We must also address the composition of Venus's atmosphere, specifically the abundance of carbon dioxide, the primary culprit behind its extreme greenhouse effect. This captured carbon dioxide, rather than being treated as a waste product, becomes a valuable resource for the production of various materials needed for terraforming, such as plastics, polymers, or even fuels. As we deploy our space mirrors, we must do so with the utmost care and precision. The placement and orientation of each mirror must be carefully calculated to ensure that we cool the planet gradually and evenly. Imagine these mirrors, each the size of a small city, gracefully gliding in their orbits, their reflective surfaces constantly adjusting to reflect just the right amount of sunlight away from Venus. This celestial ballet, orchestrated by sophisticated computer algorithms, would be a testament to human ingenuity. As we reduce the sunlight reaching Venus's day side, we can use these same mirrors to illuminate the planet's night side, which currently experiences perpetual darkness due to Venus's slow rotation. By reflecting sunlight onto the dark side, we can create more balanced heating and potentially stimulate the growth of photosynthetic organisms once we have introduced water and a more hospitable atmosphere. While mirrors and carbon capture plants work their magic, we turn our attention to the toxic cocktail that is Venus's atmosphere. The thick sulfuric acid clouds, a product of volcanic eruptions and complex chemical reactions, pose a significant challenge to our terraforming efforts. Imagine fleets of spacecraft, their cargo holds filled with carefully chosen chemicals, soaring through Venus's atmosphere, releasing their payload into the swirling clouds. These chemicals, designed to react with sulfuric acid, would neutralize its corrosive properties, converting it into less harmful compounds. We're also enlisting the help of extremophile organisms, genetically engineered to tolerate the harsh conditions of Venus's atmosphere, consuming sulfuric acid and other toxic compounds. With the heat mitigated and the atmosphere gradually becoming less hostile, we turn our attention to another crucial element for life: water. Venus, despite its scorching temperatures, is surprisingly dry, its surface devoid of any liquid water. Several asteroids and moons in the outer solar system are known to contain significant amounts of water ice. We envision capturing these icy bodies, redirecting them towards Venus, and carefully guiding their descent into the planet's atmosphere. As these icy projectiles enter Venus's atmosphere, they would vaporize, releasing their precious cargo of water vapor into the air, eventually condensing and falling as rain. As water begins to reshape the Venusian landscape, we turn our attention to the next crucial step in our terraforming endeavor: creating a breathable atmosphere. Nitrogen, thankfully, is readily available on Venus, albeit locked away in the planet's crust. Through a combination of geological engineering and perhaps even carefully controlled volcanic eruptions, we can release this trapped nitrogen into the atmosphere. Oxygen, however, requires a more elegant solution: photosynthesis. With water now present on the surface, we can begin to introduce genetically engineered organisms, specifically designed to thrive in Venus's evolving environment. These organisms, perhaps algae or specially adapted plants, would utilize sunlight, water, and carbon dioxide to produce energy, releasing oxygen as a byproduct. With the atmosphere becoming more Earth-like, the temperature cooling and water flowing on the surface, Venus would begin to resemble a more familiar world. To truly transform Venus into a second home for life, we need to jumpstart its biosphere, to seed it with the diversity and resilience of life as we know it. This process, known as planetary ecosynthesis, involves carefully selecting and introducing a wide range of organisms from Earth. Imagine vast spacecraft, their cargo holds filled with the building blocks of life, descending towards the surface of Venus. These vessels would release their precious cargo into carefully chosen locations: lakes, rivers, and newly formed oceans, where life could take hold and begin to flourish. Our terraforming efforts have cooled the fiery breath of Venus, replaced its toxic shroud with a breathable atmosphere, and quenched its thirst with life-giving water. Yet the surface of our sister planet remains a stark, volcanic landscape, sculpted by eons of intense geological activity. To truly create a second Earth, we must sculpt this alien terrain, transforming volcanic plains into verdant valleys and carving out vast, life-supporting oceans. We envision massive, automated machines powered by the very elements we've harnessed from the atmosphere, working tirelessly to reshape the Venusian landscape. Imagine colossal excavators, their blades carving deep trenches into the volcanic rock, creating the basins that will one day hold vast oceans. Picture robotic bulldozers, tirelessly pushing mountains of pulverized rock, shaping the contours of continents, and forming the riverbeds that will carry life-giving water across the planet. The task of reshaping Venus goes beyond simply moving mountains and digging trenches. We must also consider the planet's geology, its internal structure, and the delicate balance of forces that shape its surface. One crucial aspect of this planetary makeover is the creation of continents and ocean basins. On Earth, continents and oceans are formed through the process of plate tectonics, where massive plates of the planet's crust constantly shift and interact. Venus, however, lacks this dynamic geological activity. One ambitious proposal involves using carefully controlled, deep underground nuclear detonations to create fractures in the planet's crust, simulating the effects of tectonic movement. With artificial tectonic plates in motion, Venus would begin to experience a more dynamic and Earth-like geological cycle. Volcanoes, once dormant, might rumble back to life, their eruptions spewing forth a fresh supply of minerals and gases, enriching the atmosphere and creating fertile volcanic soil. This renewed geological activity would also drive the formation of mountains and valleys, adding further diversity to the Venusian landscape. Rain, falling from the newly formed clouds, would carve intricate networks of rivers and streams, carrying water and nutrients across the land. The once static and unforgiving surface of Venus would transform into a vibrant tapestry of mountains, valleys, rivers, and oceans. As we sculpt the surface of Venus and nurture its nascent biosphere, we must also address a critical factor in planetary habitability: the magnetic field. Earth's magnetic field acts as a protective shield, deflecting harmful solar wind and cosmic radiation, safeguarding life from these invisible threats. Venus, unfortunately, lacks a global magnetic field, leaving its atmosphere vulnerable to the constant bombardment of charged particles from the Sun. To protect our newly terraformed Venus, we must find a way to generate an artificial magnetic field. One ambitious proposal involves creating a massive superconducting ring around the planet's equator. This planetary-scale magnetic shield would be a crucial step in ensuring the long-term habitability of Venus. With a stable climate, liquid water, and a protective magnetic field, Venus would be poised to become a cradle for life. But creating a truly habitable world requires more than just the basic ingredients. It requires biodiversity, a rich tapestry of life forms interacting with each other and their environment. This process of planetary ecosynthesis, the deliberate introduction of life from Earth to Venus, would be a carefully orchestrated and monitored affair. We would start with simple, hardy organisms, bacteria, algae, and fungi, selected for their ability to thrive in extreme environments and their role in enriching the soil and cycling nutrients. As the Venusian biosphere matures, we would gradually introduce more complex life forms: plants, insects, and eventually animals. Imagine standing on the surface of a terraformed Venus centuries from now. Gone is the hellish landscape of scorching heat and crushing pressure. In its place, a world teeming with life-lush forests stretching across continents, their canopies alive with the songs of birds, vast oceans teeming with marine life. The air is sweet and clean, filled with the scent of blooming flowers and the gentle hum of insects. Cities, designed in harmony with nature, dot the landscape, their gleaming towers powered by renewable energy sources. The terraforming of Venus, a project of unprecedented scale and ambition, would be humanity's greatest triumph, a symbol of our ability to not just dream of a better future, but to build it, one carefully planned step at a time. The grand design, unveiling the blueprint for a new world. Today marks a pivotal moment in human history. We embark on the terraforming of Venus. This is a multi-generational endeavor. Our first steps are within the digital realm. The blueprint outlines every stage of the process. Every detail has been meticulously analyzed. We are crafting a world uniquely suited to its environment. Today, we celebrate the power of human imagination. The journey ahead is long, but the rewards are immeasurable. Section 2, Year 10, Celestial Choreography. The Dance of Mirrors and Shades begins. A decade into our ambitious endeavor, the first tangible signs of progress grace the heavens. A fleet of colossal space mirrors, each a marvel of engineering, takes its position in orbit around Venus. These gleaming giants, their surfaces shimmering with reflected sunlight, mark the beginning of our celestial choreography, a delicate dance designed to tame the fiery heart of our sister planet. Like celestial dancers, the mirrors gracefully pirouette in their orbits, their movements orchestrated by sophisticated algorithms. They capture sunlight, deflecting a portion away from Venus, gradually reducing the intense solar radiation bombarding its atmosphere. It's a slow and deliberate process, a testament to our patience and our understanding of the delicate balance of planetary energy. Simultaneously, vast solar shades, gossamer thin yet incredibly durable, unfurl in space, casting intricate patterns of shadow upon the Venusian clouds. These shades, strategically positioned to block specific wavelengths of light, work in concert with the mirrors, further regulating the amount and type of solar energy reaching the planet's surface. This celestial ballet, a symphony of light and shadow, marks the beginning of our transformation of Venus. It's a testament to human ingenuity, our ability to manipulate the very forces of nature on a planetary scale as we gently nudge our sister planet towards a cooler, more hospitable future. Five decades into our grand endeavor, we bear witness to a truly awe-inspiring event, the first rainfall on Venus in perhaps billions of years. It's a moment etched in the annals of human history, a testament to our audacity and our unwavering commitment to transforming a hostile world into a haven for life. Years of carefully orchestrated efforts have culminated in this momentous occasion. The deployment of space mirrors and solar shades has gradually cooled the planet, allowing the thick Venusian atmosphere to relinquish some of its trapped heat. The relentless bombardment of water-rich asteroids, meticulously redirected from the outer solar system, has released vast quantities of water vapor into the atmosphere. Now, as the temperature and pressure reach a critical threshold, the skies open up. Torrents of rain, heavy and relentless, lash the parched Venusian landscape. Rivers of molten rock, once a defining feature of this fiery world, transform into raging torrents of water, carving deep channels into the volcanic plains. This deluge, a planetary baptism of epic proportions, marks the birth of oceans on Venus. Vast basins carved by ancient geological forces and sculpted by our own planetary engineering efforts begin to fill with water, their surfaces shimmering under a sky slowly transitioning from a hazy orange to a clearer, more familiar blue. Two centuries have passed since we embarked on our audacious endeavor, and Venus is a world transformed. Gone is the hellish landscape of scorching heat and toxic skies. In its place, a world bathed in the soft glow of a cooler sun, its surface adorned with shimmering oceans and continents cloaked in a vibrant tapestry of green. The air, once thick with carbon dioxide, now carries the sweet scent of chlorophyll, the signature of photosynthesis. Across the continents, a verdant revolution is underway. Genetically engineered organisms, specifically chosen for their resilience and their ability to thrive in Venus's unique environment, have taken root. Vast fields of algae, their emerald hues painting the landscape, spread across the continents, diligently absorbing carbon dioxide and releasing precious oxygen into the atmosphere. Sturdy, genetically modified plants, their roots burrowing deep into the newly formed soil, follow in their wake, further enriching the air and stabilizing the climate. This green embrace, a testament to the power of life to adapt and thrive even in the most unlikely of places, marks a turning point in the terraforming of Venus. We have not just cooled a planet, we have breathed life into it, creating a self-sustaining biosphere, a symphony of nature conducted by the invisible hand of evolution. A millennium has passed since we first set our sights on transforming Venus, and the planet now stands as a testament to the boundless potential of human ambition and the awe-inspiring power of nature's resilience. What was once a hostile inferno has blossomed into a vibrant world, teeming with life in all its diversity. The skies, now a brilliant azure blue, are often streaked with the white trails of clouds, a stark contrast to the thick sulfuric acid haze of centuries past. The continents, once barren and volcanic, are now adorned with lush forests, their canopies teeming with the songs of birds, their undergrowth alive with the rustle of small creatures. The oceans, once vast, sterile bodies of water, now teem with marine life. Schools of silvery fish dart through coral reefs, their scales shimmering in the sunlight that filters through the waves. Creatures of extraordinary beauty and diversity, their forms shaped by the forces of evolution, glide through the depths, a testament to the boundless creativity of nature. This thriving biosphere, a symphony of life in all its forms, is a testament to the careful planning and meticulous execution of the terraforming project. From the introduction of the hardiest microbes to the eventual release of carefully selected mammals, each step has been taken with the utmost care and respect for the delicate balance of nature. Imagine a future where humanity has transcended the boundaries of its home planet, where the dream of becoming a multi-planetary species is a tangible reality. This is the promise of a terraformed Venus, a world reborn, where humans thrive amidst a tapestry of life both familiar and alien. As we stand on the cusp of this new era, we envision cities of shimmering spires amidst verdant landscapes, their architecture blending seamlessly with nature. Imagine floating gardens over crystal-clear lakes, their petals unfurling beneath a sky ablaze with colors. Picture children playing along the shores of vast, sparkling oceans, their laughter carried by gentle breezes through alien trees. This is not merely a human endeavor, it is a testament to the indomitable spirit of life itself. From the hardiest microbes to the most complex creatures, life has found a foothold on this once hostile world, adapting and evolving, weaving itself into the very fabric of Venus. The air, once thick with carbon dioxide, now carries the sweet scent of alien flowers, a symphony of fragrance carried on the wind. As we gaze up at the night sky, no longer a familiar expanse of stars but a swirling kaleidoscope of colors, we are reminded that we are not just inhabitants of a planet, but citizens of a cosmos teeming with possibilities. The terraforming of Venus is not just about creating a new home for humanity. It's about expanding our understanding of life, of pushing the boundaries of what's possible, and of embracing the grand adventure that lies ahead. The true magic of a terraformed Venus lies in the spirit of its inhabitants. Forged in the crucible of a monumental challenge, the Venusian spirit will be one of resilience and ingenuity. Sustainability will be a way of life, shaping every decision. The Venusian spirit will be one of collaboration, reflecting the global effort. People from all walks of life will come together, united by a common purpose. The terraforming of Venus is not the end of our journey. It is but a single step on a path that stretches out before us. Imagine future generations, their eyes filled with wonder, setting out from a verdant Venus to explore the outer solar system. Picture them establishing outposts on the moons of Jupiter and Saturn, inspired by the legacy of their Venusian ancestors. The terraforming of Venus will be a gift, not just to future generations of humans, but to the cosmos itself. This act of cosmic restoration will be a testament to the enduring spirit of life, a beacon of hope to other intelligent beings.